impressive. Nou ja. Nou, might as well do this. Include this. Let's make it an expression. It keeps on working. Might as well stop dumping the database, but it's starting to get big. So a lot of intermediate expressions, it seems. Yep, so no matter in what order the parentheses dictate how to multiply it, it gets sorted. And then we don't have output for the 10 symbols, but they were also correct. Eight symbols, I mean, not 10. Yeah, might as well copy everything, I guess, because maybe it just works in one go. I need some editing though, here and there, like the constants. Maybe only the constants. Okay, I'm just gonna copy everything. Oh no, that gets too complex here. Let's do all the way up till here. What is with this indentation failure? Let's redo the constants. delete historic stuff. No G at the end. X plus minus y. I'll just test it like this. Oh, I never implemented operator minus binary operator. Apparently, let's add it to some. Yeah, only have the plus here. Don't have a negate here. I'm not convinced product is known here though. Let's see. Apparently it is. Wait a minute, a product is derived from binary operator. Isn't it? The other namespace. Let's try this. So yeah, kind of like symbol, constant expression, and hash. So the sum comes after product, clearly. The symbol is already included as well now. Scary stuff, that's what it is. Maybe it's word symbol before an exponent, but it really should just use it. Should just sort it by base, I think, to compare B with C instead. So yeah, this seems wrong. Hello, yeah, knife to G. Yeah, it's fun. You don't need to know a lot about C++ to watch this. I mean, you need to know a little bit of mathematics, of course. If you don't know what multiplication is, then I don't think it's fun. So I'm trying to convert every formula into a canonical one. That is, I don't want to get one time A times X and another time, A times C and another time C times A, because that is way harder to compare. If it is A times C, it must be A times C, whether or not you write A times C or C times A. For that and other reasons, every product must be sorted, so the arguments should be ordered in a certain way. And here clearly it puts a C in front of the B, while the test suite expected it to be the other way. And I think that the correct thing would be to do this. The reason being that I want to combine powers. So let's say we have another B in here. Then that B obviously, I mean a symbol B would obviously get there. A, B, C, I mean that's going to be ordered like that. And then there is a distance between the symbol B and the symbol B to the power minus 4. Something sits in between, which makes it a lot harder and inefficient. And in this case even it will fail to combine the B and the B minus 4. Well, if I just order it by the base, so every exponent should be ordered by the base only, then the B just comes first. So the C, first b to the minus 4, and then C, as it should have been here. And now it will recognize this as something that can be combined because they're next to each other. So then that is replaced with it, and that's what you want, of course. So I'm inclined to say this is wrong. Another question is, how do we find out where that went wrong? Why does it go wrong? Okay, the first step is to make the test suit a little bit smaller. Just do a single test. I'm going to comment out absolutely everything. Well, I can create the symbols. Then nothing else is required. So apparently if you do C times a B to some power, this is the order that we get. Let's check if that is the case. Well, oh, sorry. That's the annoying thing about a caret. It has a very low precedence, so you must put parentheses around it. Now, okay, it says the way I fed it into it, so the order is like that. You can double check it that this is really the canonical order by feeding it the formula the way I want it. And then I suppose it will still swap it. No, I just want to C first. So at some point we are comparing. Hey Ninja. Somewhere we are comparing C with the exponent, and that is probably then in a multiply, right? I mean, that's clearly multiplication. So we're calling this operator here, which then calls product multiply. Which is this function, where argument 1 is, let's say, an exponent, and argument 2 is C, so this is b squared and this is C. So we get the type of both. Neither is a sum, so this is false and this is false. Neither is a product, actually. Well, this is false and this is false. And then we call is less. And apparently then that goes wrong. It thinks that the symbol is less than the exponent. Now the less that is being called here is the member function of product. Binary operator was the base class of product. The operator type here is product. I mean, we are in product, and product is derived from binary operator passing product. So it's not a power, therefore we do this. Compare exact, the non-constant factor. That is incorrect. We want to compare the base. I'm going to gamble something. If it's not a sum, okay, I give up. This is too difficult. Let's look at the old code, where I got this from. I think it's more complicated than this. We have an is less sum. That would be what we have to do when it is a sum. Yeah, yes, yes, yes. No, decode this. Okay, the specialization on true means that this is true, which means that both E1 and E2 are constant 3, and E1 is less than E2. Then it says if both compared expressions are constant 3, aka the true here, which means not a product or a multiplication that contains a constant factor. And that is the case in our test. Shuiful lost it again. You said the wrong word, Shuiful. Scalar 3 is forbidden in this channel. See, both compared expressions are constant 3, then we might as well compare them using is less exact. The value which we have as third parameter. Exception is when both expressions are constants. You must never return true in that case. All constants are considered equal at this level. This is going to be complex. It's highly dubious that a constant would be constant 3. But like it is described here, constant 3 means that it is not a product of multiplication. Right, next. Product. If one of the expressions, I guess, is a product that contains a constant factor, then compare the non-constant factor, ignoring the constant factor or assuming it is 1. So if E2 is constant 3, so we can just use E2 as is. And the first argument is a product of a constant with an automatically constant 3 expression. And that expression is less than E2, then of course the whole thing is true. And this is a false because this is not constant 3, so that would fail. The same for multiplication that contains a constant factor. Note that in the case of multiplication you can have a constant factor that is part of the first argument as part of a product, multiplication of a product of a constant. That would be the last two specializations. Still, as a result, the second argument of a multiplication and a product are always constant 3. So this is E1 is constant 3, and we demand that A2 is constant 3, so basically we're just comparing the constant 3 factors. So I would say yeah, it looks like otherwise just compare. the constant free factors. No, then you have an if-less product, which is pretty much the same as multiplication, which is maybe better to look at. No, I think I'm starting to see it. Yeah. But let's finish this. Kind of doing the same thing here. So this is divisible is product. It's not very useful. Skip that one. So they're not exponentiations. And E1 compares less than E2 exact. Then it's true. And if E2 is not an exponentiation, but E1 is, and the base is less. In other words, this just compares bases. Yeah. Okay, let's try this again. Product is less. No, binary operator, sorry. Binary operator is less defined here, not defined here. It's a bloody template. So if it is a sum, we have to do the non-constant vectors. If it is a product, you have to compare the bases. And if it is a power, then we should never get here, actually. Not is the same as a power. So then in the case of the product that we were dealing with argument 1 being an exponentiation and argument 2 just being a symbol, we'll now use base. And that then should work. Yep, now it puts a B up front. Then I can enable the whole test suite again. Oh, right. Yeah, I forgot the constant thing. Memory, why are you so bad? I ran into this like 2 days ago. And that's when I fucked up that is it less... No, I should fix it the correct way. I think the problem is that get base is not defined for a constant. Or was this a sum? It's not a sum. Huh? It's a product, I think. Yeah, you have -1 times a constant. So that's basically 2 constants. Yeah, it's trying to multiply 2 constants. So it is a product. So we do this. And then get base is not defined for a constant, which means, well, not defined. That means that it just uses the default, which is return as is. So then we get an is less exact on 2 constants, which might be true, and that's not allowed, as we just found. That was this remark. Except when both are constant, in which case we need to return false. Yeah, the base is only ever going to be a constant when the argument 1 itself is a constant. But we'll do it differently. Yeah, got a lot further. Well, that's not that good. Now we have b times c to the power -1. So it did not recognize that the b can drops out against the b -1 because the -1 is not distributed into this multiplication. It should have been a times b to the power -1 times c to the power -1, and then we can strike out those two. Is that true? That means that a multiplication can never be the base of an exponentiation, because it should always distribute itself. I guess so. I think so. Well, I have is product here, which calls type, and here we have an is constant of class constant. So actually, they're doing the exact same thing. Seems that one of them is a bit. What is the word? I need more tea. I really don't know what the word is, man. Come on. Unnecessary. Seriously? It's not a word I was looking for. It's more like duplicate, redundant. I think redundant is the word. I'm going to remove this one, I think. So now we should assert in the assert that I just added. It's not allowed to be a product. And then we can find who is trying to make that in the debugger. So arg1 is a product. Ooh, which complete idiot is trying to make a power product. Okay, that happens here. That's just a constructor. So argument 1 here. I mean, this is the realization of a product, right? No, realization of a power. So argument 1 is a product which was not allowed. So the problem here is that we call make power, where the base is a product. Now we go even further up. Call arg2 dot print on standard cout. Call void standard cout right. Fix this one. -1. Arg2 is -1. And arg2 is yeah, just a product. Yeah, I'm not gonna special case that here. Let's do the test then inside make power. So make power has to make sure that it never makes power of a product. Yep, so if the exponent is 0, then the result is 1. And if the exponent is 1, then we just return the base, which could be a product. And if if it is neither, then we have to distribute it over a product, if it is a product. Say if not base is product, then we can do this. Otherwise, I must do a multiplication, I think. I don't know what else happens, so just make the most general thing. Oops. Multiply. And then the basically make power of the first argument to this exponent, but I already know that the exponent is not 0 or 1. So then we have still that problem here though. But the first argument cannot be a product. So for the first argument I can call realize. Maybe turn it around. So if base is a product, then I cast it to a product. And then I can do a realize of the first argument of the product to the exponent. Multiplied with the same for the second argument. But the second argument could be a product. I have to do a recursive call. I would like to be able to skip this. Maybe instead of recursive call, use a loop. My tea is always too hot or too cold. I want to drink it and it's too hot, and then I wait longer and then I forget it. Yeah, maybe it is drinkable. No. No, I need a recursive call. At most, I could make a second make power that already knows that exponent isn't 1, 0, 1. Do we get past that point? Probably one of these. Yeah, it was this one. So the B dropped out against that B, so that worked. And here an exponentiation is lost. Oh no, actually it's not. It's here. Oh boy. Yeah, again an ordering problem. Again an ordering problem. Okay, this guy said does not recognize that this is a B. That this is base B, because it looks at this as an exponent with base B squared. So I think that the problem is that the exponents were not multiplied. They should have been B to the power minus 2. Then the base is B, then it is ordered before the C. And then you get B times B to the power minus 2, which then gives B to the power minus 1. So this is the problem. And that looks like a realize of an exponential. So I call realize with this as base and that as exponent. And realize is just a new, power. It just creates an object. So that should not have happened, because this is an exponent in itself. You don't want to have an exponent as base. So I also have to disallow exponents as base, or powers as base of a power. And then we can see where that happened. So it's not allowed to be a constant, not allowed to be a product, and it's not allowed to be a power. Very limited. Confused. It's not asserting in my new assert. Why not? I mean, I just forbid the base to be a power. So how can this ever have created? It's impossible. Didn't even compile. Did compile. Oh, arc2. Arc1. It was impossible. So now you get there. It's not allowed to be power, and it is a power. So who is trying to make this? Again, the realize comes from here. So I'm just blindly calling realize while argument 1 is a power, or maybe this one. Okay, not to do. It is already a make power 2. Obviously it is, yeah, okay, I have to extend make power 2 to also deal with powers. Must be the first one. It's a call to realize. So argument 1 cannot be a product because the first argument of a product is not a product, but it could be an exponentiation, a power. That's why it's just the whole thing. Then you can do this exact same thing, but we need to make an exponent of the base. So I first have to cast it to a power. Now I need the exponent to be a constant, otherwise it's too slow. If you want to multiply two constants, then you really want to take a shortcut. And exponents are always constants, so really why am I using a expression here? Just try to use constant from the start. Oops. Nobody knows where we are. Yeah, maybe not. Yeah. These two lines just look too much like each other. So I want to end with one of them, and then the thing that is different is what is past to realize. I'll leave it like this, maybe. And I have the same problem here, do I not? Base could be a power. So you get the same misery. If base is power, that's nonsense. It's not a multiplication. It's this one. It's the base of the base. No conversion from constant expression to constant. No member named base in power. You gotta be kidding me. Get base. I guess also get exponent then. Especially because now it's white and now I do this, it's green. Just compile. Now we're trying to make a power where the argument 1 is a constant. Seriously. Why are we doing that? Oh, if it's a product, then the first argument could be a constant. That is true. Yep. Oh boy. What? Yeah, I guess this is ugly, but it just might work. Still don't get past that point. Not argument 1 is a constant. Again? Huh? So argument 1 is a constant, okay, and I thought I just changed this. Line 35. Oh, this is a missing return here. Oops. I think we got past that point. Finally. But we have a minus sign too much, or what? There's a minus sign here now. There's a minus sign there as well. The factor of half is gone. It's also dubious to do it like that. Could negate just the first argument. To begin with. Yeah, losing the whole half is more serious. How did that happen? Damn it. So you're so not happy with these parentheses. A constant times a product should just result in becoming a product. Well, actually, it's not that simple. Maybe it is correct. Maybe the problem is that parentheses were printed to begin with. So the underlying type might be, underlying objects might be correct, but it should have been printed without the parentheses. Not sure. If you look at this, for example, I mean, it doesn't say minus a half, which is just a constant. This is just -1 times whatever. And here you see it printed like that without parentheses. But it could be that this is minus a half times this whole thing. So basically with parentheses around it. However, the parentheses are not printed because, well, it doesn't matter which order you do the multiplications. So why are they printed in this case? Guess that was a choice that I made at some point. But it would be a special case for a -1. Anyway, ignoring that for a second, let's just investigate why I lose my 1/2. I think we'll have to add just a shitload of debug outputs. So let's isolate that one test. This test. Bum, bum, bum. And then add a lot of debug outputs. Before I do that, I'm going to commit this. kind of bullshit is this? I think this should have been argument 2. There it is, okay. Same code. Yep. The end. Right. It's like a trace. Printing everything. The entry of every function. Yeah, differentiate is not necessary. This is also not necessary, obviously. Product.cxx and then power.cxx. Yeah, maybe the constructors as well, or just also realize. Maybe well, every realize calls expression get. Um, I don't know. Maybe that's the only one that I have. Binary operator and constant, I guess. Maybe the rest is defined in headers. Shall I print binary operator? Let me think. I think I'll just print opti. Why does it not get a color? Yeah, I realize it's for constants and symbols, but it's not super interesting, I guess. Oh well, maybe I should just add it anyway. And then one for the symbol. One for the symbol. I have two of them. Well, I think I only ever use one, but well. What am I doing? Undo, nothing, redo. I was trying if brace open. And nobody knows why it jumps to the top of my screen. It happens sometimes. Right, so let's see if that works. No member name, get type name. What? Why not? Exists? Oh yeah. What else can it be? Get type name without underscore? Nope. Get type. We have type info off, but I'm pretty sure there was a name in it. I don't have to do the demingled stuff. That's one. Type name. Type name of. Instant color. There's no get and off. Single test. Okay. Yep. We realize we make a few constants. That's true. We make a lot of symbols. Now the test starts. We make another constant, a half. And then I multiply a with a half, which creates the product a half times a. Well, it calls make product, which then calls product realize. A half times a. Then that, this is a new thing, is multiplied with b, which causes a to be multiplied with b, which is created, which is realized, and then we make a product a half times a times b. Realize that make a, make power 2a2, realize a2, multiply the result with c. Then we get that. Multiply -1 or that. Make product realize. Make -1 that doesn't exist yet. You gotta be kidding me. It does exist, but I'll realize anyway. Make a power. It's kind of weird that it calls realize on. I guess the reason is that I don't know where the -1 came from. Where did the -1 come from? Negate is just a minus sign, I think. Yeah, let's ignore that. It would be nice to see the return value, so I have to admit. You see realize, but I don't really see the result of stuff. Not just the realize, but also the multiply. I mean, a multiply results in a realize, I think. In this case, this one. And then we can guess what the result is, but it would be nice to just print it out. I mean, I can see it here, but it's more coincidence than something else. Yeah, I didn't have to go through the whole list. The last line is correct. It's just product of -1/2 times that. That is exactly what we want to get. And that loses the half for some reason. Get this. What? It's impossible, of course. It's like literally impossible. I think the printing is wrong. What else can this have resulted in than the correct thing? And then it's printed like that. Maybe a negative constant times something is printed wrong. Yep, that's it. See, the constant is a negative constant is just printed as a minus sign. I think the problem is in the printing. Maybe I should set a breakpoint here. See what happens. Oh, okay. No, I'm not. Georgian. Too difficult for poor Carl. Symbolic two-binary operator. It's the base class. Argument 1 is this, and argument 2 is that, and nobody knows what it really is. So the idea is that this is the correct constant. I just have to go through this hoop again. Let's first see if I can even access it. Yep. Call that dot print on standard cout, and then call void standard cout dot write a new line. It is minus 3.5. And we are here. What would my precedence be? I guess it's negation, right? Yes, negation. Which is because it's a negative constant. Yeah, well, there you see it happen. If the precedence is a negation, I just print a minus sign and then the second argument. So the whole first argument is completely ignored. Runtime differentiation is calculating the differentiation of a formula during runtime, as opposed to compile time. I'm sure you can Google differentiation. Yeah, it should only go in here if the first argument is -1. Not when the precedence is negation. That's just a wrong test. So that works, except now we still have parentheses around the constant. Yeah, it looks like a negation. No, I'm not getting it. Where do these things come from? Must be a product as well. These parentheses, right? So it's just saying that we need parentheses when argument 1 precedence, comma my precedence before. Yeah, okay, nobody understands that. What exactly does that mean? Argument 1 is a -3/2, so that's probably, I have no effing clue. Well, it's a constant, so the precedence of some constant. Damn it, products again. Symbolic 2 constant here. Yeah, so for a negative number, that's a negation. And the precedence of this thing itself is the precedence of the product, which is also negation. Ridiculous, of course. Doesn't make any sense whatsoever. What did I do here? Not even sure why this is negation here. For a product, I do the whole thing. That's not correct. Actually, I really want to have to. Yeah, it's like, damn it. Before. Can't be negation if I use before or after. It's just stupid. Let's choose product here. Let me try to understand why I would want it. Well, I think I understand it. The problem is that if you have, say, if I want to print a negation of a product, let's say I have x times y, and then I want to negate it, then I want to just put the minus sign in front of it without parentheses. Parentheses would be this, but yeah, not really necessary. However, if the product itself starts with a negative number, and that can only be a constant, okay? So this is internally stored as minus 1 times that. So actually this is minus 1 times x times y. You can make them more prevalent by saying minus a half times x times y. But then it should just be printed the way you see it now. So that would just be that. And now the idea is here that what happens if I want to print a negation of a product that is negative by itself, which is only possible when it is a product that starts with a constant, like that. In that case, I need my parentheses. However, this will never occur, because this would be internally minus 1 times minus a half times x times y, and that's not allowed. It would short circuit this and make it plus a half. So I should never worry about these two parentheses here. It's just never going to happen. It's nonsense. Therefore, I might as well ignore the possibility that this thing is negative, and a negation times a product is simply never having parentheses. Should never have parentheses. Negation being that we have to do with a negative constant, which means that well, it could be minus 1, but in that case, yeah, okay, negation is literally like minus 1, so here. So I put a minus here, and then I never want to print parentheses if argument 2 is a product. So we can ask the second thing what it is. Ask the precedence of argument 2 if it needs parentheses if being put after a negation. So the sum should return true and the product should return false. And I think it does, so that part works. And then here I had negation here, or actually I had my precedence, which simply gave the precedence of the fact that it started with a negative constant. But that's kind of bullshit, because then I ask what to do if I have a negative constant in front of a product that starts with a negative. So it's almost as if say you have this minus 3 times x, and then I call this a negation because it starts with a minus sign, and then I ask, do I need parentheses here, considering that it is minus 3 times x? But that's not true, because the minus sign is here already. Actually, this is about... No, it's not. Yeah, sorry. It's about these parentheses now. And then it would add these parentheses if x is negative, but x is never negative. And I considered it negative because the whole product started with -3. It's just complete nonsense. So I can use product here and then it would work. Should work. And for the second argument, parentheses after that, I would also definitely not negative. Let me try this one. Now it works. Let's try the whole test suite. Let's try that one line first. I should make dinner, damn it. It's getting too late. Yeah, what did I make? And now we're on the test line. Yes. So we have our -1/2 back without parentheses. Very, very good. And way, way, way too much output. Everything works. But the amount of output is ridiculous. Completely goes off my scroll. You should make a new debug channel. How quick can I do that? Not quick enough. I should just go make dinner, damn it. Yeah, that should be actually... I want to change the out entering, I think. So substitute that with, let's say, symbolic. I might even have that already. Go to the last file. Gonna be what the F. Yeah, these have entering still. Only edited the .cxx files apparently. Constant expression and symbol. Why is backspace not working? PC symbolic is not known. Okay, how do I add a new debug channel? Not using that. No, it's something like debug channel. That's what it is. Example. This is how we add a new debug channel. Now to put that in a CXX, I'll just put it in symbols, right? Expression, I mean. Can I put it anywhere, or do I have to put it? Yeah, it's a namespace, so I really have to put it outside the namespace. And this thing is called symbolic. And that must go in the header. Right. No, okay. Let's make dinner. Yeah, I guess the next step is just continuing with copying more of the old test suite. Like that. I'll